some practice questions from what we just learned for linear equations and inequalities. So let's start. So first, to solve the linear equation, to solve the variable t from this equation, t over 4 over 16 equals 1 over 6. So first of all, observing a question, so you have one equation, you have one unknown variable, which is t, so one solves t from this equation. So there's actually a couple different ways to solve it, but looking at the question, you have two fractions on either side, on both sides of the equation. Looks like the easiest way should take the cross production. So if you still remember, if we have this relationship, this equivalent to the cross production of AD equivalent to BC. Right, so apply to our question. This means if I'm using t over 4 multiplying by 6, it equals 1 times 16. So simplify this a little bit. I have 3t over 2 is 16. Right, so then t would be 16 multiplying by 2 over 3, right? Because if I'm multiplying 2 over 3 on the left hand side, it will cancel out by 3 over 2. That becomes 1. So then 2 over 3 will also multiply on the right hand side of the equation. So further simplify this, I got 32 over 3, because 32 does not contain any factor of 3, so that is the simplest form of the solution. Okay, next question, to find an unknown variable x from 1 over 10 plus 1 over 10 squared plus 1 over 10 cubed plus 1 over 10 to the 6th power equals x over 10 to 6. Okay, in this equation, we can first find where is x. So x only appears once on the right hand side of this equation. It's x over 10 to the 6th power. So on the left hand side, there's no x, it's all constant, but it's just complicated combination of constants. But it looks like if we can simplify the left hand side and to get the same denominator as the right hand side, then we're able to solve the x by comparing the numerator from the both sides of the equation. So it looks like we don't need to do anything to the right hand side for now. We only need to, we're trying to simplify the left hand side. And to simplify the left hand side, it's addition of fractions with different denominators, but there is a pattern, or there is a common thing for all the denominators. They're all multiple of 10s, so which means I can find the common denominator. So the common denominator looks like it should be 10 to the 6th power. So then my left hand side can be written as, if I want to convert each term or each fraction with the common denominator first before doing the addition, the first one I need a addition of 10 to the 5th power to be multiplied on both sides of the fraction. So later on, denominator will turn to 10 to the 6th, right? So basically, similarly, I'm doing the same thing for each term, just in order to convert the denominator into the same denominator over here. And then I don't have to write all the terms, because you soon find the pattern, because it's the multiple of 10 term by term. So then the numerator has a pattern that it's a decrease of the multiple of 10 one by one, right? So then which means I can just follow the pattern. I don't even need to write out all the terms. I will follow the pattern until the very last term, which is just 1 over 10 to the 6th power. This one, you already have the denominator of 10 to the 6th power, so you don't need to multiply any additional multiple of tens. So then I have the same denominator. It's really just the addition of the numerators to 1, and this 10 to 6. And the addition of all these, I can show you 2 of them or 3 of them first, and you will soon find the pattern. For example, 100 plus 10 plus 1, it's 111, because each digit it's 1 with multiple zeros. If I'm adding one more term, it's one more 1, right? I'm actually already there, so just write out all the possible terms, right? So basically, if there's 5 zeros, I have 5 ones plus the first one, so I have 6 ones. 1, 2, 3, 4, 5, 6, right? And then this equals the right-hand side of x over 10 to the 6th power. Then 10 to the 6th power is the same thing, can be canceled out, or simply speaking, x would just be 1, 1, 1, 1, 1, 1. That's how we solve this x. Okay, next question. If we have 2 over 3 equals x over 24 equals 84 over y, then what is x and y? Right, so this time we have two unknowns. But how many equations do we have? Even though there's only one row, one expression in one row, but there's 2 equal signs, so this actually equivalent to have 2 equations. If you only look at the first components, 2 over 3 equals 2x over 24, that is one equation, contains x only, so we can solve x from the first equation. And suppose we know, or after we know the value of x, if you're looking at the last 2 terms, that will be another equation and only with one unknown variable y. So we should be able to solve them one by one. So let's start from the first half of the equation, or first part of the equation. So I have 2 over 3 equals x over 24. I can use the cross production. I have 3x is 2 times 24, which is 48. So then x is 48 divided by 3, which is 16. Now I have solved x already, then let's check the second part of the equation. So x is now can be replaced by 16. So I have 16 over 24 is 84 over y. So you can either simplify it at the beginning, or maybe let's just do the cross production first and write out the unsimplified solution first, and then do the simplification in the last step. So I have 4 here, and I actually also have a 4 factor of 4 here, so then it's 21 times 6, so it's 126. So that's how we solve this kind of equation. Okay, so the next question is it's a word problem. So well, let's try to build the equation from the word problem, convert this into mathematical language, and try to solve that. So first of all, we know that store manager plan to distribute $50 bonus to each of the employee, but if he pays $50 bonus to each employee, then the total fund would be $5 less than what was needed. So we'll have $5 in short if $50 is given to each employee. Now, instead, if the bonus is $45 for each employee, then the fund would have a remaining of $95 left. So by knowing these two facts, how much money was in the fund before the manager started to distribute bonus? So looks like we have two statements, right? The first one is here, 50 each and $5 in short, or 45 each and 95 left. So first of all, let's determine what to solve and which term can be assigned as a variable first. So we want to know how much money in the fund, but looks like the number of employee is the key factor that can be considered as the unknown variable. And if we are able to solve the number of employees, then we will of course able to know how much money in the fund. So let's say we have X employee in the company. So then from the first statement, if I pay $50 to each employee, so 50 times X, that's the total money being paid. If I'm doing this, my fund is $5 less than what needed. So my fund, let me here just use the word fund to representing the total money in the fund. Later on, that's the common quantity. The total money out in the fund would be the common quantity to help you to build the equation. But here, let me just use the word fund. So my fund need to add $5 more so that this in this way of distribution, otherwise it would have $5 less. So this is the first fact. The second fact, if then instead we pay 45 to each employee, then we have not only the total fund is sufficient, but we actually have $95 left. So which means the total funds subtract 95, that's the money that can be used to distribute to each employee with $45 each. So from the two facts, we have the two relationships. So rewrite this a little bit. The total fund can be represented as either 50x minus 5, or from the second fact, it's also 45x plus 95. So they're representing the same fund, so which means they are also equal to each other. So then that's how we have this equation now. We have an equation such that the first way of how you distribute the bonus is equivalent to the second way of how you distribute the bonus in terms of the total fund. So I have this equation now. Now let's try to solve this one. We're going to isolate x from this equation. We can move the term that contains x to the left-hand side of the equation and move the constant term to the other side of the equation. So I have 5x equal to 5 plus 95, which is 100, and x is 20. So I have the number of employee, which is 20. So then I'm able to know the fund now, which you can plug in either expression. It will give you the same output. So I'm just plugging into the first expression, 50 times 10 minus 5. So it's 500 minus 5, which is, sorry, the number x, the number of the employee is 20. So 50 times 20, which is 1,000 minus 5, which is 995. So 995 is the final answer to this question. Basically, how much money was in the fund? That's 995. Okay, let's see the next question. The next question solves the unknown variable p from this long equation. Again, we just saw one similar question minutes ago. So this long expression contains three equal signs, contains n and m and p, three unknown variables. But we have three equations for three unknowns. Looks like we can still solve it. And if you're observing the first part or each part of the equation on either side of the equal sign, each part of the equation, you're able to solve uh, from the first expression, from first equation, you're able to solve the n, and then by knowing n, you will be able to solve the other one m, and then by knowing both m and n, you should eventually be able to solve p. So looks like this would be the way to do it. So let's try. So the first part of the equation is 5 over 6 equals n over 72. So that means I have 6n equal to 72 times 5. So n is 72 plus times 5 over 6. 6 is a factor of 72. So 72 divided by 6 is 12 by 5. So that's 60. So n is 60. Okay, so then let's go to the second part or the second equation and just copy it down first, and then we already know n is 60, so let's plug in the value of n first, and then let's try to solve this equation. We can still do the cross production, but numbers growing large, maybe it's a good idea to first simplify something. So here 60 and 72, 6. If we divide it by 6, we'll have 10 over 12 equals this. And we can further divide this by 2. To the simplest form is 5 over 6. And this. So then we can cross production. 6 times m plus 60 is 5 times 84. So I have 6m plus 360 is 420. And then moving the constant term, I have 6m is 420 minus 360, which is 60. And then obviously equals 10. It's 60 divided by 6. Okay, so I also able to solve. So I have so far I solved n is 60, m is 10. So then let's copy down the last equation. Is p minus m over 120. Now I know both m and n. Let's plug in to the last equation. I have 10 plus 60 over 84 is p minus 10 over 120. Okay, so let's simplify this. I got 70 over 84. I can at least divide this by 2. 35 over 42. In fact, there's a factor of 7. I should be able to see it from the right beginning. So anyway, so that can be further divisible by 7. So 35 by 7 is 5. 42 by 7 is 6. So this can be simplified as 5 over 6. And in fact, you can use this 5 over 6 directly from the very beginning of the equation, because once you solve those values term by term, all the terms should be equivalent to any of the term in the middle of the equation. So obviously 5 over 6 is one of the term that's available. So eventually, it doesn't matter how you plug in your known values, you always have 5 over 6. So anyway, so 5 over 6 equals p minus 10 over 120. That's the last part of the equation that contains a unknown variable. So again, by crossing that, I have 6. P minus 10 is 5 times this is 600. This time I'm not going to multiply 6 into here because I can directly divide 600 by 6, so that's just 100, and then so P is 100 plus 10, so 110. So that's how we eventually solve P. Okay, next question, I will take a look at a inequality. And to graph on the number line. So we have 7 plus x greater than equal to 2x plus 3, then greater than 12 minus x. So again, we have a mix of 3 expressions with 2 inequality signs. So we need to looking at them one by one and to get all the combination of the ranges for x, and then eventually we'll put together all the ranges all together and to find the common area or to find the intersection of the ranges. So the first inequality, we can take a look at 7 plus x greater than or less or equal to 2x plus 3. Actually, let me write down all the possible inequalities. First of all, this is one inequality. This is the second one, 2x plus 3 greater than 12 minus x. And then don't miss the last one. Unlike if this is equation, then every term is equivalent to each other, then it doesn't matter. But for the inequality, it matters. So the first expression and the last expression will form another inequality. And because even though this is a non-stricted, but this is stricted greater than, so eventually it is still 7 plus x greater than 12 minus x. So you actually have 3 inequalities, but later on you will see that 2 of them might be overlapping, or one range could be totally contained by the other range. But to be safe, just write down all the inequalities. Now let's try to solve the first one. The first one, I can subtract x on both sides. So I get 7 greater than x plus 3, and then I can move 3 over there. I will get x, so 4 greater equal to x, and usually we want to write the unknown on the left hand side, then this equivalent to x less than or equal to 4. So that's the first, let me circle this. This is from the first inequality. Now the second inequality, x can be moved over here, so I have 3x greater than 3 minus 3 on the sides, I got 9. And then I can divide by 3 for both sides because 3 is a positive number. So when I'm dividing 3 on both sides of this inequality, I do not need to change the sign. So be careful. If I'm dividing a negative number, then it's different. I have to change the direction. So here, divided by 3, I get x greater than 3. Okay, the last one looks like some moving, if I'm subtracting the x, then we get all negative sign. It's easier to have a positive sign, so I'm adding the x on both sides. So I have 2x greater than, and I'm also subtracting 7 on both sides. So it's equivalent to 12 minus 7, which is 5. So this one I have x greater than 5 over 2. Okay, so I have three ranges solving from this given inequality. Then let's try to plot or to draw the range. First one, I got x less than or equal to 4. So I have a solid dot and go this way because the less than. And the second one, x is greater than 3, but not equal to 3. So I have a circle, hollow circle, and greater than 3 goes this way. Right, and then last I have x also greater than 5 over 2. 5 over 2 is 2.5. It's somewhere over here. It's also a circle and it's greater than. You can see that the second one, the second one share the same common area, but it's okay. So then we can shadowing the intersection of all the range, and that's the final solution that's showing on the number line. And actually you can further write it down in terms of the expressions. That's the other way of showing the answer to this question. Okay, last question for today. So if we know that x is twice of its reciprocal, then what is x to the sixth power? The value of x to sixth power. So if x is twice of its reciprocal, then let's build the equation from the given condition. So x is means x equals twice of its reciprocal. The reciprocal of x is 1 over x, right? And then twice means it's further multiplied by 2. So the equation we created based on this condition is really just x equal to 2 over x. Now this is actually not a linear equation, even though so far the whole section that we learned are solving linear equations. This, by definition, it is actually not a linear equation. Why? Because if we suppose if x is not 0, then we can multiply x on both sides, and we get this equation further converted to x times x equals 2 over x times x, and this 2 canceled out. I have x squared equals 2, right? So the power to the unknown variable is higher than 1, so it's not, by definition, it's not linear anymore. It is actually a nonlinear equation. But the question is not asking you to solve x. The question is actually asking you what is x to the sixth power. So this means we don't really have to solve x from this equation. X squared, by knowing x squared equals 2, is actually good enough, right? Recall what you learned from exponents. X to the power of 6. 6 is 2 times 3. So this is equivalent to x square and taking cube, so the cube of x squared, right? So this I can decompose it the power of 6. Then why doing this? Because I know x squared is 2, so then simply plug in the 2, or to replace x squared by 2, I have 2 cube, then I got x 8. So that tells us that I don't have to really solve x from this equation further. By knowing the value of x squared, I'm able to solve this question. Okay, so that's all for today.